The book is just to cross check whether we are going in a proper flow. Okay, I'll not be just taking step by line and all. Okay, I'll be just giving you what is the important keyword from this book. And once the class ends, like I'll be sharing this mind map. Okay, I have prepared a mind map, like what are the important points you should know from this particular book. Okay, from this particular chapter. So you don't worry about why I'm showing the book and all. Just listen what I'm talking, and if you have any queries, stop me and ask me. Okay. So generally, a computer, like we are working with a computer, right? So it blindly follows the instruction. Okay, it don't know how to think. It don't know like how to raise another questions with you or nothing. It's like a blind and dumb box. Whatever the instruction has written in that, that is how it is responding to us. Okay, it's completely an instruction. So it is always good to know that you should understand the problem clearly before you write a program, because we are going to write a Python code, right? We are going to write a program. You should know how to write it, and what are the things we have to analyze clearly, and how you have to plan it properly. Okay, that is why before any programming language we used to give some sort of algorithms and pseudocodes and everything to try it out. Okay, so whatever we are programming, like whatever we are just typing, it's not just a code. It's like you have to develop a solution right from the beginning. Even if it is simple addition code, okay, you are just going to add two variables and display some output, but it needs some logic. Okay, you should know what variable you are going to use. Okay, what variable you are going to use it, what data you are going to pass it, because it's not like simply if you're going to use an integer. Okay, I hope you know what is a variable. Anyhow, I'll give you the introduction to variables as well. So if you are adding a variable, for example, if you are adding 2 plus 2, that is different in computer. If you are adding a decimal number 2.5 plus 3.5, that is a different one. Okay, because everything holds a memory and it takes some bytes to do something. So a coding is not just a programming, not just a coding. It's like beyond that, what you're going to think, how you're going to develop a solution, and how you're going to solve this entire code, right from a simple addition to a complex solution. Yes,
Okay.
any queries till this point?
No, I don't know.
Okay, so the very first step in any problem solving, if you take anything, if you take, it needs what you need to analyze the problem. That is what they have mentioned it here. Okay, the first step is analyze what is the problem is. Even if they give addition, add two numbers and display the output. So you should know what two numbers, whether it is an integer or it is a decimal number. You're going to deal with what. If they are planning to go with only integer, then how you wanted to assign with. If they are going to if they're asking you to add two decimal numbers, how you are going to design it. So everything matters. Okay, so analyze the problem, develop an algorithm, because as I told, computer is not intelligent. Okay, it blindly follows your instruction. So you have to design what logic you are going to give it. Okay, if someone is simply adding trying to add 0 plus 0, you no need to compute. Instead you can say it's 0 directly. Okay, so how you are going to write the logic, that is another important thing. And then coding, then comes coding. Okay, you have to develop an algorithm. Okay, what is the difference between this algorithm and coding? Algorithm is a simple line of instruction. Okay, for example, if you wanted to set an alarm for 5 o'clock in the morning, then what is the algorithm you will be writing? Open your mobile phone, go to the clock, set the alarm at 5 o'clock p.m. Okay, so this is an algorithm which is like a step-by-step instruction how you have to go with the solution. But in terms of it comes to the coding, you should know any one programming language, either Python or C or C++, some sort of coding you should know in order to interact with the computer. Okay, that is the difference. Did you understand the difference between algorithm and coding?
Yeah, I did.
Okay, any queries till this point?
No, I don't have any.
Okay, great. So, okay, after this, we have analyzed the problem, we have designed the logic, we have coded it. Then what is the next one is what? Testing and debugging. What is the testing? We'll be checking whether the alarm sound is properly hearing or not. First time, if you are setting an alarm for the first time, we have to test whether the alarm sound is proper, whether the alarm sound is okay for me, and whether it is set for AM or PM. Okay, so all these things you have to check. So that is what testing. You have to test whether all these things works. Even if it is like recipe, if you are cooking something, you have to test whether all the salt and everything are perfect, right? So that is what testing. And if anything is going wrong, for example, if it alarm is not like it's not ringing properly, then you have to debug it. That is, any problem, if you feel anything is happening in a different way, you have to make it proper. That is what debugging. Okay, so these four steps are important for any problem solving. This is common for even in your real life scenario. You can fix this. Okay, so you have to analyze the problem. If you're facing some challenges, you have to analyze the problem. You have to develop an algorithm how you can just plan it, like how you can solve this problem. And then if you need, you can code in your laptop, or else you can just test whether it is going good or not. Okay, so
Okay.
this is important. You will get a question from this. Okay, analyze, develop, coding, testing. Just take a look. Just take 2 minutes of time. Take a look and let me know whether it is fine till this point.
Okay.
If you have any questions, you can ask me. We will just deep dive into all these things, like what is this, like everything. But if I'm going fast, stop me and tell me that I'm going fast. Let me know so that I will tell you like how we can do it.
What is algorithm like? Is there like a definition for algorithm?
Yeah, so algorithm is like step by step instruction to solve a particular problem. This is what the definition for an algorithm. Okay, it's a very simple the definition for this. It's a step by step instruction. You will be having this here, I think, in the algorithm. Okay, so this is what the set of sequential steps. So here they have given a different way. A set of sequential step usually represented in a natural language. So, or step by step instruction to solve a particular problem. So, in a natural language is what you're using your English to say, like, this is how you can solve it. Okay, I'll show you an example for that. So, this is a example for algorithm. Okay, so this
Okay.
shows a simple way to calculate average of three numbers. If someone is asking you how will you calculate average of three numbers? Okay, so what we will say, what if you and me are discussing, what we will discuss, we will say add two numbers, divide it by 2. That's it, right? It's a very simple.
Yeah.
But the same thing you cannot expect it from the computer. Okay, so because it's whatever you say, it will follow bluntly. So you have to say from the beginning, you have to start. Okay, and then you have to read the three numbers. You have three numbers or two numbers. Okay, A, B, C, something. So you have to declare variable sum and average. I will tell you what is variable. So sum and average, and then you have to calculate the sum, you have to calculate the average and display the sum and average. This is what the algorithm.
Okay.
This algorithm, this we will not be writing it in the computer. Okay, this is to ensure that you are writing the code properly according to the computer's requirement. This is for us.
Okay. Got it.
Let us take an example. If you wanted to build a house, okay, You will be approaching a like planner who will be building the house. What the first step they will show you?
The layout.
Yes, great. So it's a layout, right? It's a template. Some template where this is how the kitchen, this is what the this is how, where the kitchen is placed, this is where the hall is placed. A small layout they'll be showing. That is what algorithm here.
Okay.
Okay. So that won't be exactly fed into the computer, but that is for you to understand how to write the code so that computer will understand perfectly.
Okay. Got it.
Clear?
Yes. I'm clear.
So here we will often use the word called variable. Okay. Any idea what is a variable?
Uh, a number which substitutes. I mean, any letter or something that substitutes another.
Okay, somehow correct. Okay, let me put you in a different example. Okay, so you have a pocket of something like let it be a snack. Okay, you have a pocket of Lays or you have a pocket of something. You have to store it. Where will you store it?
In an airtight container.
Great, in an airtight container, right? So that is what a variable. Okay, so a airtight container is not only for a lace. You can place even peanuts into it. You can place even even oil into it. You can even put some water into it. Okay, so the container can hold anything. Something which is holding something is called as a variable.
Okay.
Okay, so here if you are adding three number, that is a number variable. Okay,
Okay.
number variable where you can, the variable can be of any name. You can even use your name to store a variable. Okay, even you can use ABC to store a variable. Even you can use ABC 123 to store a variable, but it should be a meaningful name. So here they have used, because you are planning to find a sum, they have used a sum as a variable. Because you are planning to use average, they are using average as a variable.
Okay. Got it.
Okay, and in even more better terms, you might have played some games, right, in your mobile phone.
Yeah.
Yes,
I
there you can find a score, no? So the score will be increasing. Like first time if you are playing, if you have achieved some 1,000 points or something, and you have the game is over, in the sense 1,000 will be the number which is stored in the score variable.
Yes.
Okay,
I'm
next time if you are playing, and if you are taking 1,500, then the 1,500 will be stored in the score variable.
yes.
Okay, so variable, because it's varying but it holds something, it's called a variable.
Okay. Got it.
Okay, so this is how we'll be creating algorithm. We'll be writing an algorithm. Okay, so this is what an algorithm, and this is the step for completing. Got to analyze, develop an algorithm, code, test, and debug.
Okay. But I have a question. If the algorithm is just for our use, then is this like step one start and end like really like necessary?
Yes, it is necessary, because because since it's a very addition, we are just seeing addition. Imagine that you have to find the score of a student. Okay, you have to get the score of the student, and you have to calculate whether he's pass or fail, or what is his average, and running average and everything. If you design an algorithm clearly, then you will code it properly. Simply, instead of, that is why I gave an example for constructing a house. Why they are giving you a layout? Because they are well versed in building a house. They can straight away go and build a house, right? But what they will do, they will initially give you a plan, like this is what, if you need any changes, if you write an algorithm, like they will tell you, okay, here I need the changes. For example, in this algorithm, here actually it only calculates the sum of three numbers and divided by three number. Okay,
Okay.
if I'm asking you to code to find the sum and average of numbers. I'm bluntly saying numbers. You are coming up with this particular code. What I will say, I don't want to calculate only three numbers. I can calculate n number of numbers. If I give five numbers, it has to calculate five. It has to find the sum of five, and it has to find the average of five. If I am giving you to calculate 10 numbers, it has to do that. then
Yeah.
you know that, okay, so the requirement of the user is not to calculate only the three numbers. Whatever the number he or she is giving, I have to calculate. Then you will rewrite the code,
Yeah.
rewrite the algorithm, right? So that is the first step. This will give you an outline of what is really required by the user, and whether if you wanted to change something here, you can easily do it. But after developing a code, and if you are going to the user and she's telling, no, 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 I don't want this, I was expecting different one, then you have to rewrite the entire code.
Okay.
Okay.
So
So
the algorithm is like a prompt that, like, if you're giving it to a client to like see if this is what they asked for.
exactly.
Okay.
Okay. So see, you, if you are in a school, like being in a school, they will ask you to write an algorithm for everything, because so that you will know this is how the steps work. In
Okay.
a real time scenario, the algorithm will help you to understand the real requirement of the client.
Okay.
Okay. So, but if you started writing the code, and if you are very well know how to change it, how to make it dynamic, there is no need of algorithm. You can plan it by yourself.
Okay. Got
Okay.
it.
So this is for a first level of entrance. Like first, if you are writing a code, you should know what is doing. So that is why this thing.
Okay.
So if someone is asking you to write some code here, you will be starting. You will be writing this. Okay.
Okay.
Okay. Any queries till this point?
No, I'm clear right now.
Okay. I'm just opening a whiteboard. Let it open. Okay. So this is what an algorithm. Okay. So testing and debugging, this is the flow of the algorithm and how they will do. So this is a simple step, like a normal, if you are talking normally, like how this algorithm sequence will be like this. Okay. Suppose the following steps are required to ride a car. So sit on the driver's seat, put the key to the ignition of the car, press the clutch and put the gear in the correct position. So this is a step by step, but this is not exactly required for the computer coding, but this is what the normal algorithm, how it actually looks like.
Okay.
Okay, that is what they have given here. What is this algorithm and how it is.
Okay.
Okay, so I'll just show you how to write a simple algorithm. Okay, so if someone is asking you to write an algorithm to calculate two variables, or to find the addition of two variables, so what you have to do, step one is always a start, because you have to start the coding. Step two is what, read two numbers. Two numbers. So the algorithm is not like what exactly given here. It's not like what is given here, you have to write exactly the same. No, it's like a casual discussion. Okay, read two numbers A and B.
Okay.
Okay, you have to read it. Then step three is calculate two numbers and store it in a variable called sum. Variable sum. Okay, sum is my variable. Okay, even if you can make this as add. In your real time scenario, your school may tell you that, okay, you have to add two variables and store it in add variable. Like the two variables, you have to add it and store it in the variable called add. In that case, you have to make it as add.
Okay.
If they ask you to add it and hold it in a sum, you have to make it a sum.
Okay. Got it.
Okay, so here they have usually used with sum. So you can do it. Okay, add. So again, this is how I will write the code. Calculate two numbers and store it in a variable add. Example, I'll just give an example. If you have to follow that, like add is equal to a plus b. Okay, if you wanted to follow this, you can also do this. Calculate sum of three numbers. Example, yeah, they have given an example on the right side. Okay, so actually my requirement is just to add, right? So I have added and calculated it, and you have to display the output. Okay, display the output, add. Okay, now there's two numbers, right? So this is the number a. For example, if someone is giving a is equal to 5, b is equal to 10, a plus b, that is 5 plus 10 will be added 15, and that will be stored in add variable.
Okay.
Okay, and it will be displayed in the output, and you have to stop it. Okay, stop or end. Okay, this is mandatory.
Is there a step necessary to like run the code?
No, this we will not run. This is an algorithm for our purpose, so we will not run it.
Okay.
We will be writing this code in Python or something in a programming language and we will run it.
Okay.
You cannot run an algorithm. Algorithm is just for your understanding.
Okay. Got it.
Okay? Okay. So you can take 1 minute time. Let me know if you have like you if you have your book with you, you can just go through quickly and let me know if you have any question.
Okay.
You need if you need more time, you can let me know.
No, I'm good right now.
Okay,
I've gone through.
fine. So again, I'm telling as till this, I wanted to give a key point that algorithm is nowhere related to your computer. It's just for a human understanding. Like you can think about a documentation or whatever you are buying. For example, if you are buying a hair dryer from Amazon or something, you'll be having a manual, right?
Yeah.
That is what algorithm. Okay, just simply to understand that okay, my thing is this is what I'm going to write, whether whether this will work fine or not.
Okay.
Okay, it's very simple. Let me just show you that in how it is actually written in a code. Okay, konjam.
Okay.
Okay, so this is a Python. We will just visualize it how it will work. Okay, I hope you can see my screen, right? Okay,
Yeah. I see.
so now we are going to add two numbers. Okay, I have my algorithm here. What I have to start, I have started this particular website. Okay, and then what they have told is read two numbers. So which means that I need two number. Okay,
Okay.
so I'm just randomly typing, like for example a, I'm giving a value for a and I'm assigning a value for b. Okay, I will explain this code, don't worry, just see how this algorithm is actually converted into a code.
Okay.
Okay, then what is the next step we did? We told to add two numbers, right? Example, add is equal to a plus b. So I will just do add is equal to a plus b.
Okay.
Okay, this is what, then what you have to do, you have to display, right? In Python we will be using print. Print is a function to display whatever you want.
Okay.
Okay, that's it. What we did, start, read two numbers, calculated, displayed the output and stop. This is how you will instruct the code. Let us just visualize the code now. Okay, so you can see this is the place where you can see how it is actually visualized. Okay, in the right side you have to look into this point, frames, objects, right? You have to look here. Okay,
Okay.
now let me just, so now actually your code is here. Okay, this is the place where your code is. You can see the arrow mark. Okay,
Okay.
so now what happens here is what, now a is assigned, 5 value is assigned to the a variable. Here a is called as a variable.
Okay.
1 minute, let me reshare it again. Can you see now?
Yeah, I can see it.
Yes. So here you can see this is a number which I have assigned to this variable. So if you look into this particular code, what happens initially when that first line of code is executed, your variable is assigned to this value a, variable a. This 5 is assigned to the variable a.
Okay.
Okay. Now what happens? B is assigned to, sorry, 10 is assigned to B because my second line is executed.
Okay.
Okay. Now what happened here, because since I'm trying to add a and b and I'm holding it in the variable called add, now we can find that the a and b are added and the value is now holded by add variable.
Oh, okay.
Okay, if I print add, then your output will display like this because it's a print function. Print function is used to just display as it is. It won't hold anything. It won't do any process, just it will print it. So you will be finding an output like 15 or whatever it is, you can find the variable like this.
Okay. Yeah, it's
Okay,
clear.
this is what happens in your Python. Even if you execute something in the Python code, it won't show you what is happening step by step, but when you run the code, immediately you will get the output as 15.
Okay.
Okay, within few milliseconds you will get it, but exactly this is what happens in your backend.
Okay.
Okay, so for example, if I am missing something, okay, this is why I told you to write the code. I am not asking you to read the two numbers. For example, okay, if I missed this particular step, okay, let's make it like this is the step 3, this is a step 2, and I'm displaying the add here. So what happens when you are writing the code? Okay, what we'll be doing is what we will miss this. Okay, because I haven't asked you to initialize a and b, right? Directly
Yeah.
it is a plus b. So now what happens if you execute this code? See, immediately it will show you the error because it is telling you a is not defined. You haven't defined a.
Okay.
Okay, so if you are very familiar with the coding, then you will understand that okay, a is a variable which I have to define previously and b is the something which I have to define previously, so you have to write the code.
Can we say add equals a plus b and then we can write a equals this or that or b
No,
equals.
it cannot find it because it's a good question. Actually, Python is a step by step. It will execute one line by line. Let us
Okay.
try this, because you had the doubt, right? Let us try this. B is equal to 10. Let us execute this code. Again it will show the error because the first line you have mentioned add is equal to a plus b, right? So anyhow if you wanted to execute that line, it needs the value for a and b.
Okay.
Okay, it won't even go to the next line because it couldn't find a and b, so it is stuck there.
Oh, okay.
Okay, so Python is a step by step coding, like it will execute line by line, and if something goes wrong in the first line, it won't execute to the next line.
Okay. For example, if you are solving like a formula, like I mean, like a quadratic, some formula, if the question like it usually gives the question and then gives x equals something or like y equals something, and then we are supposed to substitute it. That's like I thought that even if you say add plus a equals b or something
Mhm.
else, when we give the next component a equals something, I thought it will first like understand that a we are supposed to do this and then go to the next step and it
Okay,
understand.
that is a different case where you can get the dynamic data from the user. Okay,
Okay.
you will be getting the value dynamically from the user.
Okay.
Okay, so dynamic in the sense what? You will not assign the variable in the first time. Okay, so but you will get the value when whatever the value they require, because here we are assigning the static value, that is a is equal to 5, b is equal to 10, like that we are just assigning the value which is a static one. So if you wanted to get the value from the user, you have to write accordingly. For example, you have to write like input. So input is the function to get the data from the user dynamically. But
Okay.
anyhow, so input A, okay, you will be getting input B, and then you can say add is equal to A plus B, which means that you can get the value. Okay, so anyhow you have to assign what is a variable here. Okay, so you have to tell um okay, this will take like you should have this programming Python with you, so we will see this. Okay, once it is done, you can make it like for example, you can get the data from the user directly, but for that you need something to do before.
Okay.
Okay, even if it is a quadratic equation, you will be doing this formula here, something somewhere like this, but you can get the data from the user. For example, let me just put it like this: input, and for example, b is equal to input. Okay, so okay, so here, see here, now it is asking you for the input, like for 10, and then if I click submit, then you can get 15. Submit, then it will add the value to it.
Oh, okay.
Okay, but I haven't said that this is integer or a string. So that is why you should know the basics so that you can understand what is happening better.
Okay. Yeah.
Okay.
So because this is just a variable, it's just adding, it's just combining 10 and
Yeah, it
15
is
and
assuming that as a string value. String, that is your name is a string, right?
yeah.
Your name is a string. If I'm trying to add Jillu and Gomati, it cannot do the proper integer addition. It will simply concatenate Jillu Gomati. It will just print like Jillu Gomati. It won't add it. So since we haven't defined the type of a data, so it is assuming that as a string and exactly printing 10, 15.
Okay. Yeah.
Okay.
And
Yeah. So your question is correct. Even if it is a formula, before that we have to get the data. Like even if it is a random data, you have to pass it. We have to initialize the string variable, and then we can use the formula here.
okay.
Okay, like how we are using it. So you will be getting it randomly, and we will initialize the formula here.
Okay. Yeah. I understand.
Yeah. So this is what okay, so this is what we have discussed. So these are the characteristics of the good algorithm. So what are the characteristics? In the sense, it should be well defined what are the input and what are the output, because even if you miss one single step, the algorithm will go wrong.
Okay.
Okay, and it should be clear and unambiguous. Like clear in the sense, even if you are assigning a variable, so if it is a, instead of holding it in a sum, you cannot simply say like ab is equal to a plus b, because people cannot understand what you're trying to do.
Oh, okay.
Okay, and it should be finite number of steps. Like your algorithm should not go beyond your asking for additional pages. Okay, so it should
Okay.
be precise and small, so that not as small as possible, but it should be properly written. It should not go beyond the limit.
Okay. Like
Uh,
if there, for example, if there is a code that goes beyond the, like for example, I've seen the open source of, like Google Meet something, and it's like very long. So if
mhm.
it's, so is there any change in the way it acts if it's smaller? Like,
They will make it as a, they will decompose it, like they will make it as a modules and rate it.
oh, okay.
Yeah, so this is what, like once you start writing the code, you will understand, okay, this is a module which has to be like make it separately. Okay, you will
Okay.
make it separately, and for that particular module you will write one code, and for another, for if you take a simple example, if you take an ATM, you are getting into the ATM, right? You can
Yeah.
see a lot of options like balance checking, saving, like multiple options you are just seeing. Okay, immediately it is not striking out, but example, if you say 5 options, it is showing. You will
Yeah.
not be writing the entire code for the 5 options. You will split it into different one. For one option, you will write one algorithm. For another option, you will write one algorithm. Like that, it will go.
Oh, okay. So, is it like a blog where, like, there are some
Yeah.
separate sections? Okay.
Okay. So it's a good question. So you will not be writing it for entire thing. So that is what finite number of steps, so that people can understand.
Okay.
So you have to imagine, like you are writing an algorithm not only for you, that is for everyone. Those who are trying, even if I'm seeing that, I should be able to code it.
Okay.
Okay, and you should say what is the input. An algorithm always receives an input, so you should say what is an input, and always produces an output.
Okay.
Okay, why input and output? Even if you take your mobile phone, there should be some input, right? Your screen, you have to just touch it. It should show something to you on the screen. So
Yeah.
anything which requires input as well as the output.
Okay.
Okay, and the algorithm should be practically feasible. It should be feasible enough to implement and design it. So it should be complex. Hey, how I can use this algorithm, like that we cannot, you should not think it. So it should be feasible, and it should be ready to be implemented in a coding part of.
Like, can you give me an example which is which in where
Okay.
coding is not feasible.
Okay, so this is a simple code, but if you take some code, for example, if I am writing this, okay, even if it is, if I am not telling how to add this, okay,
Okay.
I'm simply, because since it is an addition, you can understand. If I am asking you to find the logarithm of some numbers, okay, or differential calculus of a number, and I'm simply saying calculate it and store it in a differential, some variable, but I am not giving you any example or any input for that, the people cannot understand,
Okay. Yeah.
right? It should be properly and clearly defined, and it should be feasible and ready to implement. By seeing this itself, I should know that, okay, this is the flow of this code where I can easily make it as a code. I showed you, right, with this algorithm, how I wrote the code. You can easily write the code. But
Yeah.
imagine, can I write a code with this algorithm? Because it is trying to store it as a differential, but I'm displaying an add. What is happening here? So people cannot understand.
Okay. Yeah. I understand.
Yeah, so this is what, like, it should be feasible and it should be ready to implement, and also for the coding, and it should be ready for any coding language. See, not only in Python I should be able to code. Even if I wanted to type it in a C code, I should be able to do it, because this is a common instruction, right? It's not dependent on see, for example, if it is a C, I can code it like this. Okay, do you have C code? No, right?
No, we only have Python written.
Okay, great. You are all escaped. We have C and VB when we were typing. So include conio dot h. You see, I'm very much flow in that, because we have it's a very complicated code. Your C is very complicated. So if I see this is a common thing. Okay, this include conio or common to every code. So this is common. Whereas in C, I will be defining like int A and then int B.
Okay.
Okay, and int add is equal to A plus B. So this is how I'll be coding it in the C. And I'll be doing printf. Okay, printf add. That's it. Your C code is over. Okay, so you should write a algorithm where you can easily implement in any coding language. Whatever the coding language you are trying to implement, it should be easy to do it.
I have a question. Like
Yeah.
in the C++ or the C language, you have mentioned int A and int B for the, for it to understand that it's an
Mm.
integer, not a string. So in Python, we are not mentioning int or anything, but how does it
It will.
understand that it's not a
Yeah,
string?
Python, that is what the power of Python. So it is not a, like, you don't need it, it's dynamic language we called. So based on your data, it will understand what you're trying to print. Okay, and here, because previously we haven't specified whether it is an integer or not, so it is easily understood.
Yeah.
It will do it. So that is a dynamic language. It can easily understand whatever you are trying to do. You no need to specifically say this is integer, but even if you say, it won't uh, mm, think that it is harm. You can
Okay.
even say that, okay, this is an integer.
Okay. But then, if even if we say it's an integer in Python, like it's just we're just giving it the knowledge it already has.
Yes.
Okay.
Okay, you don't need to say, but it will understand. If you want to say, you can say that, but it will easily understand that this is what you are trying to do it.
Okay. Yeah.
Okay, it's a good question, because that is why I wanted to show you even but C is not a dynamic language. It's a very strictly coded language. So you have to specify everything. If you miss int, it will show you error. For everything, it will throw error.
Oh. Okay. Yeah.
Okay, yeah. So this is how you should write. So your good algorithm, this may be your 2 mark question. What is the characteristics of a good algorithm?
Okay.
Okay, can you just have a look? So for, in order to understand this, you can have abbreviation, okay, or you can have a mnemonic. Okay, puff oil puff or puff oil. Okay, you can make it as like which puff, right? Which puff, like that, oil puff something. So O is for output, I is for input, L is for language dependent, P is for precise, U is for unique, and 2F is for finite and feasible.
Alright.
Okay, you can remember with this, just take a time and remember now itself so that you don't need to take an extra time to um,
Okay. O
so
is for output.
obviously, yes.
Yeah.
Yes, you can continue. O is for output, I is for input, L is for language dependent, language
Language
independent.
independent. P is for precise, U is for unique, F is finite, and another F is feasible. Okay.
Yes.
Yes.
So this you should be able to expand it, like by seeing that itself you can write. And whenever you are highlighting the characteristic, like the this one, the output, if you highlight it, the people, like those who are correcting the exam paper, they can easily understand that something. They will not see everything. They just need what is the characteristic. They won't see the expansion and all. So
Okay.
make sure that you are making it possible. Like all these things should be remembered.
Okay, the bolded ones should be like written in a
Yes.
unique way so that they can. Okay, yeah.
And it should be correct. Okay, instead of output, don't write something else. So
Okay.
output, input, language independent, precise, your unique, feasible and finite, this should be correct. Apart from this, in your explanation you can write whatever is coming to your mind on that, like algorithm receives some input, algorithm is giving you some output, something like that. You can just build it up, but this should be correct.
Okay. Yeah.
Okay, shall I proceed or you want some time?
No, you can proceed.
Okay, can you just tell me what is the flow of an algorithm? Like what should be there in the algorithm? We just discussed, right? What is
So
yeah?
first, like this, the step one is the start, and then
No, no, no. I'm asking this. Like, what is the problem solving steps?
oh, okay. So first we have to first we have to see the problem state, the analyze the problem statement, and then after that we have to develop an algorithm
Very
so
good.
that the humans that who the people who if they the other people can see it, they'll
Hmm.
understand how to code it. It's like a what is it like a
Yeah.
basic layout for others to understand, and then the step three is for the coding in any specific language, and then
Hmm.
after you code we have to test it and debug the problems or anything
Very good.
errors. So,
Very good. So, even this question is asked in a 2 mark, you have to draw this particular image. Okay. Don't forget, whenever this question is asked, even if it is in a 2 mark or 5 mark, 10 mark, whatever, wherever, if it is, draw this image, and then if you feel like expanding it, explain properly. And if it is only a 2 mark, you can just give one word, one sentence, and then leave it. Okay, wherever required, wherever possible, include the image, which will
okay,
give
yeah,
you some hold, like the correct, like those who are evaluating your thing, no, they will understand. Okay, this girl is written something.
okay,
Okay, shall we proceed? Is
yeah.
it fine? Do you have any doubt? You can ask.
No, I don't have anything right now.
Okay, so again, this, while you're writing an algorithm, you should be very clear about the input. Okay, if you miss the input, people will definitely find it very hard to find like what you have to give as an input.
Okay,
Okay, and you should show what is the computation. What is the computation here? Here we have added, right, like add is equal to a plus b. So something, a computation which has equal to, that is before and after, before something equal, before that should be there before the equal to, and after equal to that should be there to compute something. So this we will call it as a computation.
okay,
Okay, like an expression. Even if you take a simple interest calculation, that is, calculation is a computation. So there should be something to compute. Okay, what computation or what you're processing or what you're computing in your in your code and output. These three things are very much important for any of your algorithm.
okay,
Okay, so
yeah,
this is the representation of algorithm. Usually we will represent it as a flow chart. Okay, flowchart should have a start or end. A start has, it's an oval like symbol. Like this, we will be drawing a flowchart.
okay.
Okay, it's an oval.
Is
And
this
then,
like
yeah.
are these symbols like integrated in the coding, like with
No,
site
no, no,
or
no,
like?
no, no. No, no, no.
Oh,
It won't be integrated in the coding. We'll be either designing it in a Word document. I'll show you in the Word document, or else you can create it in a Paint, or else you can. It has specific tool as well, like eDraw. There are a lot of tools to design this,
okay.
but you can do it in your Word itself. That is fine. And again, this algorithm is nowhere related to your exact coding. In your compiler, you will not be designing the flowchart, or you will not be designing an algorithm.
Okay.
Okay, it's like a complete blueprint. On seeing that, you can write it. So you may have a question. Already I have an algorithm. Why should I draw it in a flowchart?
Yeah, that's the thing. Same thing.
So few people have a better understanding of a picture. Instead of writing it, they can easily understand through the picture. Okay, so
Okay.
a flowchart is a pictorial representation of a algorithm.
Oh, okay.
Okay, so you can see, even if it is a building construction, it will be a pictorial representation, right? So they'll
Yeah.
be showing, and also they will give you like hall, what is the square feet, and if it is a kitchen, what is the square feet. They will also have some written thing, but if it is like in a picture format, people can easily understand.
Yeah.
Okay, so that is what flowchart makes complicated process or task easier to understand. If instead of writing it in the algorithm, if you just go ahead with the flowchart, it will be even more easier to understand. So that is why people go with the flowchart instead of algorithm. It's not mandatory that you have to do both algorithm and flowchart. Any one is fine.
Okay. Yeah.
Okay, but initially, if you are writing any code, your teachers may insist you to write both algorithm and flowchart in order to make you better understand.
Okay. I think I
Uh,
prefer the algorithm better than the flowchart because like differentiating
yeah,
the shapes is like a big challenge
no,
for
it's
me.
it won't be big. I'll explain you easily, because if you are writing an algorithm for a complex code, you will find very difficult, but flowchart will be even more easier.
Oh, okay.
Because there will be looping. You have to, if this is happening, then go to this. If this is not happening, go to this. Like, there are some looping and branching options will be coming up there. So there you will find flowchart as easier than algorithm.
Okay, I guess since I'm only like exposed to like the small coding, I
Okay.
guess I feel better with the
Algorithm,
algorithm.
but you just get familiar with the flowchart. We will make it possible. Okay, it's very simple.
Okay.
Okay, so let us just try to design an flowchart. Before that, you just understand the symbols. Okay, so if you want to start or stop, you have to go with the oval symbol.
Okay.
Just imagine a switch. If you are oning, switching it on, switching it off, it's a oval symbol.
Okay.
Okay, and to connect between one step to another step, you need a arrow mark to say that this is how it is flowing from one place to another place.
Okay. Yeah.
And if something is like a process, for example, add is equal to a plus b. You are doing some process, right? That should be in a rectangle.
Okay. Yeah.
Okay, and you are getting an input and output. So if you are asking to input or read or something, or output or display something, you should use a parallelogram. That's it.
Okay.
Okay, this decision and all we will see later. Only for basic thing, you need only these things.
Okay. So
Okay, let me, yeah, tell me.
so that that condition or the decision, that thing is okay. If we're
That will
asking
come
for,
later.
okay.
Don't worry about it. Okay, it will be easy. Okay, don't worry about it. That we will see when the condition or anything comes in.
Oh, okay.
Okay. So what is our algorithm? Let me just go. If you want to draw it. Are you familiar with Word?
Yeah, but I prefer Google.
Yeah. Okay, Google Docs. You want to go with Google Docs or Word is fine?
No, anything is fine.
Okay, I'll show it here. If you are finding it hard in the Google Docs, let me know. I will explain you in the next class. Okay.
Yeah, sure.
So in the Word, you can see there is an insert. So
Yeah.
if you just click on this insert, you can see shapes.
Okay.
Okay. So here you can find all these things, oval, so whatever. So I'm just selecting this shapes, and let us just go ahead with this oval. You don't have the okay, here you have for flowchart you have a separate section. Can you see here? This is a separate section for flowchart.
Okay, yeah.
Okay, so just click on this, and we used to draw it with a visual draw, like we have a different thing called visual draw, and then just come and draw it here. You can see a picture coming up here.
Yeah, okay.
Okay, double click, you can whatever the data it is, you have to go with start. It's compulsory, so every for any picture start and stop it's confirmed, so you can give start.
Okay.
Okay, and then again go here, you can see an arrow button here. Okay, so this is an arrow shapes, and click on this, just pull it out, so you can find the arrow here.
Okay.
Okay, and then what is now, just think and let me know what is for reading and writing, like printing and getting the input.
Uh,
Just try.
the
It's a
input.
yeah,
Okay. You're asking for the input, right? For the input, it's the parallelogram, the
very
flat.
good. So here you have a parallelogram. Okay, so it mentions like a data. Just bring it here. You can see the data. Okay. So of course you need it for output. So just copy and do Control C and Control V and keep it here.
Okay.
Okay. So here we are simply creating a flowchart for addition. So let me just go ahead with read A comma B. Okay, and then copy this line, there is an arrow, and paste it. For everything you have to use this line in order to show the flow.
Okay.
Okay, now think and tell me what is for the process or computation. What
That's
is
like a
the
rectangle.
great? See, you are correctly telling, then why you are worried about the flowchart?
No, I don't know. Like at first, like the identifying the shapes was like a challenge for me. I don't know why.
No, it is actually easy for you. You are just telling very fluently. So read and then you have to compute, right? So add is equal to a plus b. I recommend you what you are using it here. If you are using a capital letter A and B, then go ahead with capital letter A and B. Okay.
Okay.
If you are using small letter here, go ahead with small letter here, because few languages are
Case
case
sensitive.
sensitive. Yes, good. So because we have to write the write and draw the algorithm and flowchart for every code, right? Every algorithm, every language. So it is always good to go ahead with whatever you are as declaring. Also use the same case sensitive thing.
Okay.
Okay, A and B, and then you have to find the thing that is print or display. So either instead of read, you can also use input. Okay, we used to do this input, read, whatever is fine. And here display or output, whatever is fine. Display or output. What we have to output?
Uh, display add a plus b.
No, display add. Okay,
Okay.
that's fine. Because yes, usually people have the confusion. That is why I asked you. So because this is what we have to display. All that is why I also showed the Python. Okay, so it this will be added and which will be stored in add.
Oh, okay. Yeah.
So again, you don't need to print a plus b. So add is fine.
Okay.
Okay, clear?
Yeah, it's clear.
So finally, what we have to do? Whether our
Uh,
flowchart is complete?
end it with like
Very good.
stop or
So you
end.
have to end it. See, you are very fluent in flowchart, then algorithm, I think. So you can try this because this will help you then algorithm. Algorithm is really very, it will take at least 5 pages to write any logic or something. If you're trying to create, it will be very hard.
Oh, okay.
So I'm just copying and just bring it down. Okay, so bring it down, make it a stop or end. Okay, whatever, like, but it's always required, like start and stop is required. You can use end or stop, whatever it is, teachers will accept, but without ending you should not do it. Okay,
Okay.
so where this flowchart will go wrong if you are missing this flow. Okay, so I have removed the arrow mark, right? If the arrow mark is not there, then the flowchart is stopped here itself. If the arrow mark is not there, then the flowchart stops here, and it means like you didn't stop the flowchart.
Oh, okay. I
Okay,
have a question.
yeah.
Like, can we use a connector from like display to stop, or is it only mandate that we have to use the arrow mark?
So it is only to go with an arrow mark. When the connector will work is what I'll show you, because you're curious about the connector. So for example, if my flow is going like this, okay, so I have one more, just I'm showing it. I have one more, some processing or displaying. I have one more chart like this, like one more computation is coming up here after displaying. And
Okay.
if my flow chart is going to the next page,
Oh, okay.
okay, then what I will do, I will use the connector here. If my stop is going here, then I'll be using a connector, because I cannot simply show, my flow will end here, right? My flow will end here. So
Yeah.
what I will do is I will add a small circle. Where is the circle here? So I will draw a small circle here. Okay. And even this circle should have connected with this flow chart.
Okay.
Okay. And I will draw the same circle here in the next page.
Oh,
Okay.
okay.
And then I will connect this arrow mark here.
Okay.
And
Instead of
I,
writing out,
yes,
okay.
I
Ins-
will give the name for this connector A. In that case, here A is also mentioned here.
oh, oh, alright.
Okay, so this is how the connector will work.
Oh, okay.
Okay.
Instead of like putting that, like it's continued in page two, we're just using a connector.
Yes.
Alright.
Sometimes you will be having condition. When we are learning a condition, so the condition will go in a different, if you are condition based program, if it is taking to the 2 pages or 3 pages. Now there will be two branches. You have to tell which is connecting to what in the next page. So that is why we are labeling it. Okay. If condition yes, if it is A, then next page the condition yes, A is continued. B, there is another connector we can connect with.
Okay.
Just I can understand your curiosity. See that this is what the connector. For a simple code, we will not go with a connector. We will just go with the flow, like a single arrow mark is fine.
Okay.
Okay, clear with this?
Yes, it's clear.
Great. So this is what they have given the thing here. So this is what we have tried. Okay, they have tried with the average. We tried with the simple code. Okay, this is an average oval shape, parallelogram, rectangle of processing, draw a parallelogram, and how it ends.
Okay.
So this comes your if and else. Shall we continue? You are okay with this, or you need to go with some many simple problems and then continue with the branching?
No, it's okay. We can continue with branching.
Okay, then I will tell you. Like, see, you have. Let us go with a simple example instead of coming here. Okay, I'll just go with this. Now you have a condition to check for whether the student is pass or fail.
Okay.
Okay, so what we'll be having, a thing like, or can you tell me in the algorithm, like how we will be getting it? Step one,
Step one is start.
step two. Let us see, let us take like you have to check for the condition. If the mark is greater than 40, then the student is pass. Okay, let us assume like this.
Okay.
Okay, student pass. Okay, step two, what you have to
Uh,
get it as an input.
the input is if whether to check the student is pass or fail, right?
The input is mark. First you have to get the input, right?
Okay.
Get the input, get the mark as an input. Okay, so algorithm is whatever you wanted to write, you can write. It's not like only the same word you have to follow, nothing like that. Get the mark variable as an input. Okay,
Okay.
then now comes your condition. Check the condition.
If mark is greater than 40 or less than 40.
If the mark is greater than 40, okay,
Okay.
if the mark is greater than 40, then it's true. Okay, true or false.
Okay.
Then go to step 4. This is why I told, if you are checking the condition, algorithm will confuse you. Okay,
Okay.
it's pass. display pass. Okay. Again, you have to write else. If the mark is not greater than 40, then go to step 5. Okay, step 5, display fail.
Okay, yeah, this is understandable.
Then what is the last step?
Stop or end.
Got it? Did you understand this particular thing? And then let me know.
Yeah, okay, I understand it.
So let's let's draw the flow chart here. So again, you have to go here and insert the oval flowchart. Yes. So it's a start. Okay. And then let me just, I think I'll just draw it here itself because it's taking much time for me.
Okay.
But when you are drawing, please write in the word or something which helps you better. Okay. So here you will be writing start. Okay. So this is start. And
I have a
then,
small question.
yes, please.
If is this like to draw a flowchart, is it usually asked in like theory or like practicals?
It's in both. In the
Okay.
practicals, mostly they want you to write the code Python, so they won't ask you to write the code. Sorry, write the flow chart or the
Algorithm.
algorithm. But
Okay.
provided if they feel like if the practical external will come, right, if they want you to write it, they will definitely ask you to write. So it is better to better make it as a practice right from today. Whatever the basic code you have, start with algorithm, design a flowchart, and then go with the coding.
Okay.
Okay. So it's always better to be ready.
Okay.
Okay, so this is your input. I'm just getting the input as mark, right? So input mark, and then next one is what you, instead of processing, because we don't have any process here, right? Instead of processing, here comes your condition. Okay,
Okay.
because if is a condition, right?
Yeah. If the mark is greater
So
than
yes, very good. Mark is greater than 40.
is mark
Okay.
supposed to be inside that like
Yes.
quotes? Okay.
Yes. So quotes you are asking, right? I usually didn't use the quote. Even here they haven't used the quote, so no problem.
Okay.
So if it is, then you have two branches, because if it is, what happens? If it is not, what happens? So there are two things. You have to label this. Okay. Don't forget to label yes and no. This is
Okay.
mandatory. Then if it is yes, then what you have to print? It is
Pass.
pass. Okay. So print pass. Then if it is not, then print fail. So you have to get this.
Okay.
This is a simple example, okay, so that you can easily understand with the marks. Print pass and print fail. Okay, whatever you are printing it in the double quotes will exactly display the same thing. It can be not a case sensitive. It can be a case sensitive or not a case sensitive, no problem. Whatever you are printing it inside double quotes.
Okay. Uh,
Oh,
I have a small question. In the diagram, they have given the pass and fail as a crosses a rectangle.
now here they have computed something.
Okay.
Okay, they here they have display. The display is properly in the parallelogram, right?
Yeah.
So in your, so this is little this is the next level. That is why I'm giving you a simple example for you.
Okay.
Okay, if you want to bluntly display something, you have to go with a parallelogram.
Okay.
Okay, and then you can connect the both here. Even here you can get the connector. Okay, so you
Okay.
can connect the both here as a connector,
Okay.
and then finally you can end this with the oval end or stop.
Okay.
Okay, this is a simple example. If you want to print something directly, if yes or no goes, you can use the parallelogram. In your example, the requirement is different. So percentage year end bonus of each of its employees earning. So you have to compute 7% bonus.
Okay.
Okay, so so Speed Net Limited plans to give 7% year end bonus to each employees who are earning 20,000, greater than 20,000
Okay.
or more per month, and a fixed of 1,500 who are earning below that.
Okay.
Okay, so that is why if you have to compute something, then you have to use the first one, the processing, that is a rectangle, and then the display is common, right? So it will go with the display.
Okay.
Clear?
Yeah, it's clear.
But in our case, we are not doing any processing and all. So pass fail only. It has to just print it. So in order to print it, you have to go with a parallelogram. Just print it and finally you have to stop it.
Okay.
Okay. So I'm just stopping it here because next thing it will go a little beyond. Before that, is that okay for every Sunday if we can meet, or else you want in between? If you are free in the night, you can let me know.
Okay. I
Oh,
guess that for most part, Sundays are more convenient. If
convenient. Okay.
yeah.
If any exams are nearing, you can let me know. We will plan accordingly. And
Okay.
I will share this flowchart with, like, sorry, it's in a mind map. Okay, I'll share this mind map with you. Just go ahead with this. And I will give you some problem as an example, like exercise. You just try it, take a snap, and send it to me.
Okay. Should I do? Can I send it to you via Google Docs or something?
WhatsApp, anything you can, it's fine. Even you can, initially I recommend you to go ahead with using your pencil and paper. Pen and
Okay.
paper, draw it and send it to me. That is fine.
Okay. Yeah.
Okay, draw and send. Write and send. Instead of typing, write it. Comes in, whatever comes in, write it and send it to me.
Okay. Yeah. I'll do that.
Okay, yes, great. Any questions? I'm just I'm just giving a summary of what we have learned today. We understood what is a problem solving. Why should we go with a problem solving, and what computer can do and what you should do.
Okay.
Okay, and then what is the steps for the problem solving? These are the 4 steps. Whenever asked, just draw this diagram. And can you remember what is the characteristics of the good algorithm?
Oil puff. Okay. Output, input, language independent.
Very good.
P is precise. U is unique. F is finite, and another F is
Feasible.
uh, feasible.
Good. Okay, great. So that is important. Okay, what is that? Your characteristics of an algorithm, that is it is really required. And then your algorithm. What are the symbols of algorithm? This can be in the 2 mark or 3 mark, whatever your structure is. Okay,
Okay.
be very careful about this symbol as well as the name of this, why it
Okay.
is, and name of this. And then we discussed two basic problem. So this is one basic problem and one if condition based problem. Okay,
Okay.
I'll give you some exercises to try. Do it and send it to me. If it is, I will advise you to go with the paper and pencil. If you are okay with only with the document, go ahead with that.
Okay.
Okay. Okay, if you have any more doubts still, you can ask me.
No, I'm 100% clear right now. I
Okay,
know.
great, super. Okay, we will meet next week, but until then I'll be giving you something. You have to just, whenever you get time, proceed and give it to me.
Yeah, sure.